Okay, my friends, today we are going to discuss some more rational graphs. And I know we've done a lot of these this unit, and I'm going to add a couple new things, and we're just going to strengthen our skills in drafting these rational functions. We've talked some about horizontal asymptotes, but today I'm going to give you the official rules. The only thing that matters when you're checking for horizontal asymptotes is the degree of the top and the degree of the bottom. So if you look at this equation to the right, the degree of the top is 3, the bottom is 2. What happens is everything else in the equation is meaningless when x gets really, really big. Right? And that's what we're talking about, horizontal asymptotes. What happens when x is like 1,000 or negative 1,000 or 1,000,000 or negative 1,000,000? What is this graph approaching? The only thing that matters is the leading term. In this one, you can see that the degree of the top is bigger. The top is cubic and the bottom is quadratic. So what's going to happen is there are 3 rules. Number 1, if the top is greater than the bottom, then that means none. Meaning as x gets really, really big, this cubic is going to, in a sense, dominate this quadratic, and the difference between them will grow, and it will approach infinity. All right, if you plug in, 1,000,000 in for x, you're basically going to get a huge, huge number. Maybe positive, maybe negative, but the point is, it's not going to approach a certain value. It's just going to keep growing and growing and growing as x gets big and small. Number 2. If the top equals the bottom, which we've talked about some before, then the horizontal asymptote is the ratio of leading coefficients. Spelling there. But if these had both been squared, then you just take whatever's in front of the x squared and the x squared, and if this were 2, then we would have negative 1/4 as our asymptote. And we've done a few of those before. But just take the ratio of the coefficients. In this case, we do not have that either. We have none because of our degrees. But if they were the same, you would take that ratio. All right, number 3. If the top is less than the bottom, then the bottom, in a sense, is going to dominate, and then y equals 0 is going to be your horizontal asymptote. All right, it'll approach the x-axis if the top degree is smaller. Because what you end up with as x gets really big is a big number over a gigantic number, which basically makes 0 in the long run. All right, so there are rules for horizontal. Number 2, we'll go back up and draw the graph in a minute. But number 2, slant asymptotes. So what this is a line, a tilted line, not the axis or a perfectly horizontal line, but a slanted line that your graph will approach. This is going to occur when the degree of the top, I know it's not very math teacher-like to use the words top and bottom instead of numerator and denominator, but it's a lot, I want you to be able to remember this. So when the degree of the top is 1 greater than the degree of the bottom. So if you look at this equation, our degree on top is 3 and the bottom is 2, which means we do have a slant asymptote. So it would be nice to know what that line is. Where does that slant asymptote show up? And here's how you find it. Basically what we're going to do is long division and we are going to ignore any remainders. All right, so we just take our equation and divide it the old-fashioned way. We're going to divide negative 4x squared plus 4x plus 8 to numerator x cubed minus 2x squared minus 3x. All right, so let's do that long division. All right, I'm going to encourage you to pause your video, do the long division, and then resume. I'm actually going to pause and write it out and then resume to keep this length down. Pause. Okay, so I'm back, and you can see that this long division, it's a little bit uglier than they normally are. I need to ask myself, what do I need to multiply negative 4x squared by to get x cubed? And that's negative 1/4 x. Distribute and write that below and subtract, and then the next time I need to multiply by 1/4, I need to multiply this by 1/4 to get this. And you can see that's why I put a 1/4 on top. And really you can stop there because everything else is just going to be forming the remainder, and I'm going to ignore the remainder anyway. So after you do long division, this is your slant asymptote. All right, so again, if the degree of the top is 1 greater, you're going to have a slant asymptote every time. How do you find it? Actually do the division and then ignore the remainder, and the equation that you get, which should be a linear equation, is your slant asymptote. So negative 1/4 x plus 1/4. Let's add that to our graph, because all the graphs from here on out are going to ask you to do slant asymptote if there is one. Negative 1/4 x plus a fourth. Let's see, plus a fourth, so I'm going to be crossing just here. And then I have a slope of negative 1/4. So I'm going to go down 1 over 1, 2, 3, 4, which is about right here. Down 1 over 4. So it's not it's a little awkward, but I can handle it. So this is the path of my slant asymptote. Remember to make your asymptotes dashed or dotted to imply that they are not part of your graph, but they are important to know where they go, so we can find our, or plot our graph more accurately. All right, so now we also, let's see what they're asking us for. Horizontal, which we just talked about, and we don't have any. Slant, which you just learned how to do and added to your graph. Everything else is stuff you know how to do. So let's just proceed like normal. So the first thing you always want to do is factor the top and the bottom. On the top here, I can factor out an x. I'll be left with x squared minus 2x minus 3. And on the bottom, see how that'll factor. I think about that. Pause a moment. Okay, so I'm back, and if you need to pause for a second and get those factored, do that. So they weren't the most obvious, they took a second. But anyway, it's factored, which is always your first step. Now we identify our holes and asymptotes. First of all, x equals negative 1 is a hole because it was canceled. Now, if you want to know the location of that hole, plug negative 1 into the canceled out version. If you do that, you're going to get negative 1 times negative 4 on top, which is 4. And on the bottom, I'm going to get negative 4 times negative 1 minus 2 is negative 3, which is 12. So unless I made a little arithmetic mistake, my hole is going to be at negative 1 1/3. All right, so negative 1 1/3. Looks like it's pretty close to that asymptote. I guess it's right. Let's see here. It's just below that asymptote. Right there. All right, so there's a hole in the graph. My vertical asymptote is going to happen at 2. Okay, because 2 makes the bottom 0, but not the top 0. Here's my vertical asymptote. My x-intercepts are values that make the top 0 that did not get canceled out. So at 0, right here, and at 3, I have x-intercepts. Y-intercepts are the values that you get when x becomes 0, and since The top is 0 when x is 0. We also have a y, if there's an x-intercept of 0, then there's also a y-intercept of 0. So that point I've already taken care of. So my x-intercepts were 0 and 3. My y-intercept just 0. And what else do we have? We've identified holes, vertical asymptotes, intercepts, and slant and horizontal. So that's it. We have, let me change the points that are actually on my graph to blue so I can not confuse them with the points that are part of the asymptotes. So I've got a hole and 2 points. And I can pretty much tell what's going on. I can maybe plug in a couple other values just to double check. But the asymptotes kind of trace out where you're going. I've got to basically come up like this, getting really close to that asymptote, and down like this. And then with a hole in the graph, I'm going to go like that and like that. Okay, so you can tell that's similar to the horizontal asymptote graphs that we do, but it's just tilted for the slant asymptote. All right, so if you're ever unsure whatsoever, just plug in another value. I'm going to try, f of 8. You plug in 8. You can plug into the canceled version if you want. You get 8 times 5, or 40 on top. And on the bottom, you get negative 4 times 6, which is negative 48. And this is negative 4 times 6 is negative 24. So this is negative close to 2, somewhere between negative 1 and negative 2. So that's right down here, really close to my asymptote. And then you can, do the same, plug in a number like negative 8 or another value. I cannot stress enough, if you are at all unsure, and you should do this anyway because sometimes you don't know you're unsure, plug in some points and make sure they agree with everything you've done. Okay, so wrap this thing up. We have done all but 2 of these things before. We've done some horizontal asymptotes as well, but officially now, horizontal asymptotes only depend on the degree. Slant asymptotes, if the degree at the top is 1 greater, we're going to do long division, ignore the remainder, and that line that you get, if you're looking for a linear equation, is the slant asymptote, and your graph should approach that just like any other asymptote. So that is going to wrap up our formal discussion on rational graphs. We're going to do lots of these to practice. Hope you enjoy them. This is Washington Bartholomew Hogwallop, and I'm out.